let's think about how hydrogen bromide might react with this thing right here. And let's think about what this would be called. We have 1, 2, 3, 4, 5 carbons. It has a double bond right here. If we start numbering at this end, because that's where the double bond is, then this would be pent. This is pent. The double bond starts at the number 1 carbon, pent 1, and it's obviously an alkene. It has a double bond, so it's pent 1-ene. Sometimes this is called 1-pentene. 1-pentene. Either way, so let's think about how these two characters might react with each other in some type of solvent. Usually when a solvent's not specified, it's usually water or alcohol. If this was water, then this would actually be, we would have a solution of hydrobromic acid. But let's not worry about that right now. Let's just worry about how these two characters might react with each other. Now the first thing we might look at is this hydrogen bromide right there. And as you get more experience there, you'll say, well, bromine is much more electronegative than hydrogen. It likes to hog electrons much more. And if that's a completely foreign concept to you, I'll do a little bit of a review. This is the periodic table. Electronegativity increases from the bottom left to the top right of the periodic table. Electronegativity. Electronegativity. And really, that's just a fancy way of saying how much does an atom like to hog electrons. So for example, fluorine loves to hog electrons, and calcium doesn't like to hog electrons so much. So if we think about hydrogen bromide, hydrogen's way up here on the left side of the periodic table. Bromine's all the way to the right. Bromine is much more electronegative. So in this situation, since bromine is more electronegative, it will hog the electrons in this bond. And since it's hogging the electrons in this bond, you'll have a partial negative charge on the bromine end. You'll have a partial negative charge on the bromine end, and you'll have a partial positive charge on the hydrogen end. And whenever you do these reactions, it actually is useful to draw all of the valence electrons. So bromine right here has an atomic number of 35, which means it has 35 electrons in its neutral state. And we don't have any charge here, so it's in a neutral state. But you can look at its group. It's in group number 7 if you count from here. 1, 2, 3, 4, 5, 6, 7. Or it has 7 valence electrons. So let me draw that. 7 electrons in its outermost shell. Let me draw them right here. So 1, 2, 3, 4, 5, 6. And then the 7th is in the bond with the hydrogen. Hydrogen obviously has 1 electron. Hydrogen has 1 electron. It's right there. So these two guys are bonding with each other, and they both allow each other to pretend that they're part of a pair. And that's what gives it a lower energy level or makes it a little more stable. That's why the bond forms in the first place. But anyway, let's think about what might happen here. This guy is really electronegative, so maybe he wants to hog this. Maybe he wants to take this electron away, this green hydrogen electron, and maybe that happens. Maybe that happens. But that can't, let me just draw it out. So maybe that happens. So he takes that electron, that green electron away. It's just getting closer and closer. If there's only some other place that this hydrogen could get an electron from, then this guy could just go to the bromine, which is what bromine really wants to happen because it's so electronegative. So where can the hydrogen get an electron to replace the one that it's about to lose? Well, we have a double bond here. And maybe one of these carbons lose an electron. And in future videos, we'll talk more which one is more likely to give up the electron at this stage of the reaction. But just for simplicity, let's assume that this carbon right here gives up an electron. Where are its valence electrons? And just as a bit of review, here's carbon on the periodic table. It has 6 protons and 6 electrons in its stable state. 2 are sitting in its first shell, and then the other 4 are its valence electrons. And you can see that it's in group 4, right? 1, 2, 3, 4. We can ignore these for now. And usually you're not going to be dealing with, well, we'll ignore those for now. It has 4 valence electrons. Most of what you're going to deal with, you just have to count the group numbers like this. We won't worry too much about all of the metals and all of those right now. Now it's 4 valence electrons, and you see it right here. It has 1, 2, 3, 4 valence electrons. It has 2 in its one shell, so it actually has 6, but you only draw the 4 out there. So what we're saying is this green electron can go to the bromine as long as the hydrogen can take an electron maybe from this carbon right here. So let's draw that. So this electron right here is going to go to the hydrogen. And when that electron goes to the hydrogen, simultaneously that will allow this electron to go to bromine. And obviously they won't be this far when it happens. There would be some type of collision that would have to occur in just the right way, with just the right level of energy for this to occur. Maybe the hydrogen is getting really close to this part right at the right moment when this electron is being sucked away from the bromine. So this has a partial positive charge attracted to the electron. That electron goes over there. It won't always happen, but this is a potential reaction mechanism. But this whole step happens at once. This electron goes from this character to the hydrogen at the same time as hydrogen loses its electron to the bromine. So what's going to happen right after this step? What's going to happen right after this step? So right after that happens, what will everything look like? Well, we'll have the bromine will have gained the electron. So it's now a bromide ion. So let me draw it like this. So it had its original 7 valence electrons, 1, 2, 3, 4, 5, 6, 7. And now it just stole an electron from the hydrogen. It was able to swipe an electron off the hydrogen. That's the electron it swiped off the hydrogen. And now what will this thing that was 1-pentene or pent-1ene, what will this look like now? Let me draw it. So we have a carbon and a hydrogen and a hydrogen. And then you have a carbon and then a hydrogen. And then you have the rest of the chain right over here. You have the rest of the chain right over here. But this double bond was broken. This carbon lost an electron, went to the hydrogen. So this bond right here now forms between this carbon and that hydrogen. So let me draw that bond. So this bond, actually, let me draw it. You have this electron right there. That electron will now be with the hydrogen. So let me draw the electron. And now we have that orange hydrogen. I'll try to keep the colors consistent so that we know where things came from. And then we have this bond now to the hydrogen. Now this carbon now only has 3 valence electrons. 1, 2, 3. It has 2 sitting in its first shell, so it actually has a total of 5 electrons. Has 6 protons, so it has a positive charge. This carbon right here has a positive charge. And another way to think about it is it was completely neutral, and then it lost an electron. So now it will have a positive charge right over there. So this is what we are left after that step of the reaction. Now, as you can imagine, oh, and of course, we can't forget, bromine over here was neutral. It had 7 valence electrons, and that's when bromine is neutral. But now it has 8. So now this will have a negative charge. This will have a negative charge. This will have a negative charge because it gained an electron. And in general, your total charge over here, our total charge is 0. So our total charge should still be 0. We have a negative and we have a positive. They would cancel out. So our total charge is still 0. So what's likely to happen for the next step of our reaction? Well, we have this positive thing here, and maybe bromine just bumped just the right way to let go of this guy and steal his electron. But now you have this guy who's negative and this guy who's positive. Maybe they'll be attracted to each other. Maybe they'll just bump into each other at the exact right way. And if they bump in the exact right way, maybe this guy can swipe the electron from the bromide ion, from this negative ion right here. And you might say, hey, isn't bromine more electronegative than carbon? Well, it might be, but this guy's electron rich. It's not just a regular bromine atom. This is a bromine plus an extra electron. So he's already hogged an electron, so he's electron rich. So in this situation, he's negative, he's positive. He can give this guy an electron. So if they bump in just the right way, this electron can be swiped by this carbon right over here. By that carbon right over here. And this positive carbon, just to give you a little terminology, and we'll go over it in more detail in future videos, is actually called a carbocation. It's a positive ion of carbon. That's where the word comes from. But anyway, if this electron gets swiped by this carbon, it'll then form a bond. Because remember, this was the electron that was originally in a bond with this hydrogen. It's still going to be, you could imagine, paired up with this other purple or magenta electron right over there. So if that happens, then we're going to be left with, so the next step is going to be, so on this end of the molecule, we have C, carbon, hydrogen, hydrogen. Then we have this orange hydrogen that we stole from the hydrogen bromide. Then we have this carbon right here. It has a hydrogen. You have the rest of the chain, CH2, CH2, CH3. And now, since this guy stole an electron, bond will form with the bromine. So now, let me draw it. Let me draw it. So he's going to steal this. Let me draw it this way. So a bond will form. He's stealing this electron. So now this electron is with this carbon. So I can do it as one end of the bond. The other end of the bond will be that magenta electron right there on the bromine. And now the bromine lost an electron. So it's neutral. It once again has 1, 2, 3, 4, 5, 6, 7 valence electrons. Carbon is now neutral because it gained an electron. It once again has 1, 2, 3, 4 electrons. So now everyone is happy again. So in this video, we were able to get a mechanism. We can talk in the future about how likely it is to happen, how quickly it might happen. But we were able to start with hydrogen bromide and 1-pentene or pent-1-ene and get to this thing. And just by pushing around electrons and just thinking about what is likely to happen based on what's electronegative and what might be able to gain or lose an electron. And just a bit of a review, what is this thing right here? This might be, let's see, this is 1, 2, 3, 4, 5 carbon still. So it's going to be a pent. It's now an alkane, no double bond, so it's pentane, and it has one group on it. So we'll start numbering closer to the group. So 1, 2, it's 2-bromopentane. 2-bromopentane. So we were able to figure out a reaction mechanism to get us from hydrogen bromide and 1-pentene to 2-bromopentane.